Okay, welcome to Pesterize Your Code. I'm Jim Arruda. I'm your host for this evening. Just a quick couple questions. How many of you haven't used Pester at all and want to learn more about it? Wow, okay. Makes me feel better. Thank you. How many of you have already using Pester and kind of want a refresher or looking for a little bit more? All right. How many of you are like Pester masters? Damn it. I was hoping to get some people in the audience who can answer some questions for me. Okay, last question. Does anyone know the history of Pester? How Pester became to be? Anyone know? So, that's a little bit about me as I go along, tell my story. I'm a former public high school teacher. I used to teach physics. So I'm a science background kind of guy. So Louis Pasteur, who invented the process of pasteurization, which does what? Kills bugs in milk, basically, right? He has an ancestor that was recently discovered. His name is Joey Pester from Rhode Island. He invented the process, pasteurization, to kill bugs in code. And how it came to be was, hey, I'm Joey Pester. Hey, my cousin Louis did one time, he killed bugs in milk. So, hey, that's a good idea. I want to kill some bugs in my code. That's my best joke, folks. I'm sorry. That's Okay. So here's the agenda. So we'll go over a little bit about my story. So this is my second summit. And this is my first ever contribution to the PowerShell community. I figured I'd start small and present a session at the PowerShell Summit. All right, might as well go big and go home. We'll talk about why am I pestering you, and hopefully after this session, as you talk to more people, as a lot of people would want to get more to Pester, you stop pestering each other. And eventually, hopefully after this session's done, I've given you enough to take away to help pester yourself. So where do I start? That's basically what kind of helped me to begin. I came to the session last year, and Don Jones was going to do a talk on Pester, and there was a big mishap with Delta, and the original person wasn't going to be able to present it. Don took it over, and he had technological problems, and it was a challenge, but Don pulled it through. He's done. He is what he is. So from there on, I wanted to reach out and talk to people. It's like, how did you guys get started? I'm having such a hard time getting started. It takes me so long to write the tests, and I have so many problems. So we'll go over a lot of those things. Now what? Okay, now we'll go over into some of the basics of Pester. We'll go over what makes up a Pester test. And I don't want to spend too much time on it. I'll kind of make this like a level set. It's fairly simple, what consists of a Pester test. And we'll start getting into writing some. How dare you mock me? So we'll talk about mocking. So some of my background, I came from like a system admin type role. I'm not a developer. Basically working toward development-minded in testing, so take like test-driven development. And so with mocking, you have to be able to mock a lot of functions that you're using in some of your code. So you can write unit tests. And we also get into integration tests later. Well, I have a bunch of examples where I have unit tests and I have integration tests in cases for both. And mocking is very crucial in unit testing. We'll talk more about that later. And we'll put it all together where I have an example where a lot of my job that I currently do, we integrate with REST APIs. So I have an example test on how I do a unit test against the REST API and then how I run an integration test against a little test environment to make sure that code works with Pester. And we'll sum it all up and do some questions and answers. Hopefully some Pester masters who can help me with that. All right, why are you pestering me? So it's a big question. Why test? It's a lot of work. Yep, we have to write more code to do tests, and you hear a lot. I have to write twice as much code, and well, how many people don't like writing code? Yeah. So right, that's not a problem. So what is the problem? Oh, I don't have the time. Like I'm Kim Fitzhusband, I know exactly what it's like. Oh, I have this problem I need to my bosses came to me, I had to install all this software, or I got to set these services on fire the machines. I need to write a script right now and make sure I need it done by 2 o'clock. So does that really inhibit time to give you time to write the tests appropriate? No, it's tough. A lot of us have had that situation. I had that situation. And there's no really easy solution around it. It's just, you just got to do it. Just got to try to make time to do it. And a couple things that prevented me from getting better at testing was some of the things I was doing. So we'll go in a minute. So why test? So the other thing that's important for testing is it is an investment, right? Invest your time. It's an investment in your time. And that investment over a long haul will pay off. Does anyone have any personal stories they could share with maybe that because they wrote a test saved them a lot of heartache later? I'm asking that because I don't have many of my own yet. Because I've been really careful, and I've been lucky enough to do some tests to help catch some of those things. So how many of you took a flight to get here? All right. So why test? Was it a good? Was it good that they tested the plane before you took off? Yeah, I hope so. So there's my picture there. This is not copyrighted, I made sure. Now I say, a lot of people say, oh, you know, you're a dummy if you don't test. Well, I say, be a dummy, test first. Crash this dummy. So make sure you actually do the tests. And like I said, you invest the time, it will pay off in the long run. And one other thing, with writing tests, it actually almost acts as like documentation. It's like free documentation for what your code does and how it works and what the behavior is, because that's what Pester really is designed for, is behavior-driven development. All right, so where do I start? Things I learned. So the first thing, I have an example here. I'll switch over real quick. So simpler code equals simpler test. What does that mean? Exactly. So here's a sample code I wrote many moons ago of a function, and this was for Dynatrace. We have Dynatrace as an application performance monitoring thing. So this is to add another agent, a .NET agent, to a machine remotely. So you can see how long this is, and I'm doing a lot of things in here. I'm like, wow, I'm so proud of myself. I'm awesome. And I also wrote some tests for it, even more awesome. And I would say these are examples of what not to do. You can see how long and how tedious. This took me so long to do, and then I'm writing tests, and like, why is it failing? And I have a script that's so long, and I'm putting in breakpoints and write verbose, and where's my script breaking? So what I end up doing, learning, is if I write a module, let me close these down for a second. So here's a module I'm going to use in our example, is I modularize the module. So whatever action I'm going to perform in my code, I made it its own function. So here's my little test for demo for services. So I have private functions, or I'm just going to get some data, and the functions I want to execute are my public functions, ones I want to be able to run. And those will be my set my services to running. So yeah, not exactly real-world examples, but at least I'm doing something for the demonstration. So I went into this. So I went down in, basically I switched to this methodology of breaking down my tests into smaller components, which then resulted in much simpler tests. So here's, you know, obviously this is going to be small, not a big deal. And my set, I have a little bit of logic in there so I can show some unit testing. And my tests for that are just as simple, just as small. As an example of the unit test for this. Everyone see that fine? So nothing too crazy, right? Seems manageable. Break it down. So that's one takeaway I had. Next was start with what you know. So you're writing a function, you're writing some code. Hopefully you have an idea what you want it to do. So I would say that's what you start with for the first test. It's like, oh, I want to get this data. So I write the little function and get the data, have the test for that data. Boom, you have a test. Is it testing everything? Not yet, but are you testing? Yes, we're getting there. Test easy things first, kind of comes in with what you know. So you start with what you know, and if that may be simple, start with the simplest part first. Get it out of the way, it get you going, give you some momentum to get on the roll. And this is like writing code. So if you're in a spot where you're writing your script, and this happens all the time. Oh, you get pinged. Oh, I need this right now. Somebody set my password. Oh, okay. You come back, and then you have to take like 10 minutes to start over again. So it's sort of like, if you start with the easiest thing first, you get some momentum, you build some momentum up, and before you know it, you wrote 3 or 4 tests. And you're like, wow, this is fun. Pester's fun, yay. Mocking. So here's the big one. So for unit tests, and especially when a lot of stuff that I write, I'm sure a lot of you have written if you like sysadmin type background, even some developer, is you're doing a lot of stuff remotely. So write unit tests, you have to be able to mock those calls or those actions that you're doing so you can test just the code that you want to write. So we'll talk more about mocking in detail in some of my examples. So understanding what to mock. So mock is a tricky thing. So you're mimicking, so in my example, I'm getting service, and I want to set the service. So when I get the data, analyze what the status is, then I want to set it. So I have to understand what it is I need to mock. So I'm going to mock my get service, understand what it returns to me, and I'm going to mock that. And I'm going to pass that into my test, and then analyze the logic in my code. Go into that in more detail. Then just do it. Just got to do it. Just rip the Band-Aid off, get it over with. Like this session for me. I've been really nervous. A lot of people in here, there's some people in here who know probably a lot more than I do, and they're in this room, and I'm like, oh my God, hope I don't screw up. So let's get into some demo. Okay, so let's first start with the basics. All right, how are we doing on time? Doing good. So, where am I going here? Okay, overview. So here basically is a overview of what a Pester test looks like. So on the top, everyone see that okay? We're good in the back? In the top, I call that like the foundation block, where I load up, I dot source my script files or modules that I need to use to load in the test, so the test can run and execute. So whatever it needs to do to execute the test. The next is the Scribe Block. That basically, let me minimize this here. You can see this better. There we go. Read that okay? The zoom in kind of messes up the. Oh man. Let me bring this down quick. Makes it easy to read. Is that a little better? Okay. So the Scribe Block is what contains a group of tests, and it basically is what some people will call it the test container. So that basically defines what you're going to be testing. So you have a name for it, and you can tag it. So here's my example. I have a name test token. This is an actual one of my tests I just copied in here, and I tag it unit. So you can actually put a tag on a test as a unit test or integration test. So when you go to invoke Pester later, if you don't want to run a whole series of tests, you can specify one by name or do it by tag. And you can specify just the unit test you want to run, execute all unit tests, or then specify the integration tag and execute only tests in integration. Then you have the context block, which is like the grouping of like, I kind of use it for scenarios. So in my examples, I use it as a scenario, like if the service is stopped, expect this behavior. If the service is running, expect this behavior. So I use those to kind of group out scenarios. A lot of people use them for a lot of other things besides scenarios, but that's how I kind of use them. Does that help explain what the context block is for? All right. So it block is basically the test itself that validates the assertion of what you're looking to be true or false. So in the example there, I invoke my get token function. I evaluate the token name, and I expecting that name should be token broker. If it's token broker, it returns true. The test passes. If it's not token broker, it returns false. Test fails. And that's a Pester test. That's about it. Not too bad, right? Even I could do this. So let's look. We'll get into more of this here. So here's my function get bits. This is in honor of Jason Helmick. So if you watch the Microsoft Visual Academy, all the PowerShell examples I've ever seen uses get service bits all the time. So I'll start the same thing. So I have a function get bits. I get the service name bits. And here is my get bits. Here's my test for get bits. So I dot source the function, so I can then execute it within the test. I named it test bits. I tag it as bits for basically no reason. I just put a tag in there. I'd put a context block in there also. There's no reason for doing that for this case. I'm just showing the test structure. And I have a test. It should return bits. So I verbalize my output from get bits function. I analyze what the property name will give, and it should be bits. So as a little test, let me go into that directory. I will invoke Pester. Oh, here we go. Here's the intelligence thing I was talking to Rob about. Okay. I will put test bits. So I'm just going to run the test bits test. I have one other one. Skips over the one that does not it, and boom. Yay! Nothing's broken. Okay, well, okay, big deal. We tested get service, which should work 100,000% of the time. So, moving on a little bit more. One other thing you can also do is code coverage. So if I invoke the same test again and add the code coverage parameter, I then give it the test, my function that I just wrote, execute that, and it gives me a little code coverage report. So that's a nice little way, nice little utility to actually gauge how much coverage your functions have based on the test that you've written. So as you write tests, you just execute the test, execute code coverage. If you don't have 100%, obviously you're missing something. So it's a good way to gauge what's going on. Also, you can export, I think XUnit XML, so you can plug this into a build and add it to a pipeline. So you can, if you have a pipeline to build PowerShell modules, you can run code coverage as part of that build, export the results, have a quality gate to analyze it, or you have the data to make sure that you are meeting a certain percentage of coverage. It's pretty cool. So one thing I want to show here in this example with get token is I do have a mock in here. And to quickly talk about mock, kind of get into how do you mock me. So for mocking, it's basically we're mimicking a particular function or a command or whatever you want to, basically some kind of action. So what I'm basically doing is I'm mocking get token. So for this example, I want to make it a little easier to follow. So I'm mocking my function that I loaded earlier, my PS1 file, get token. It's easy to read. And read that fine? Okay. And I'm passing in a return, and I'm basically creating a property name, and I'm giving that name token broker. How do I know to do that? I just smashed my microphone. I'll be making big noise. So if I run get service, or better yet, let me dot source get token. Typing in front of people is not fun. Now I'm going to run that. And this is what it returns. Okay, what is that exactly? So it's a, what is that? So it's a property type name service controller and it has all the bunch of properties. And the ones I'm the one I am interested in is name. Sorry about that. I stutter when I get nervous. So I have name here. Oh, it's at the top of the alias property. Service name and status and display name. So display name, not a big deal, but two I'm going to be using my demonstration is name and status. So what I'm mocking is I'm actually mocking the get service commands return. So in order to understand what to mock, you have to understand what you're going to get from what you want to mock. So I want to mock get service in my get token function, which is all that's in there, which is the only command I'm running in there. So even my mock get token, so I can either mock the get service, but in this case I'm mocking my function get token, which returns the same thing because it's just get service basically. And I'm going to return that as a property, come on, with just all I'm looking for is the name. So yep, there's a bunch of properties that were in there, but what I'm only interested in is the name. That's what I want to test for. Am I getting back that same name? So I mock that, I execute get token, and I'm looking for the name. It should be token broker. So let me do that now with this test. And there's one way to prove. There's probably multiple ways to prove, but the one I use, I tried using debugger and Visual Studio Code, and I have issues with it sometimes. Okay. So I'll call it then test token. Execute that. Of course, it passes. Well, of course it's going to pass. You told it exactly what to expect. Duh. Yep, question.
Yeah, so line 12, that get token
Yep.
is the mocked version that you
Correct.
created in 10? Okay.
Correct. Yep. So when I actually call it, Pester is mocking that and just giving it a return. So it actually doesn't even run anything. And to prove that, I ran a code coverage earlier, and you saw it was 100%. If I do that again, for this file, because I have a mock in there, what do you expect to see? 0%. It didn't actually run the function, the call in the function. So voila, mocking is working properly. And what we can, what's also nice about code coverage is if something, question?
You should be mocking get service.
Yes, correct. Yes. I should be mocking get service. In this example, I just mocked my function. In my other examples, I mock what I should be mocking. I'll see. You'll see. I'm sorry if I made that unclear. So what's actually nice about the code coverage, you see what line, it's smart enough to actually tell you what line was not covered in your function. And you can go back and make sure you have coverage in your file. Okay, so that's basically basics of some Pester testing. So let's get into some more meat and potatoes here. I like to call Shrees and peppers of my session. I know none of you know what that is. I'm from New England. It's a Shrees thing. It's Portuguese, whatever. You can look it up. Okay. So let's get more into mocking. And to make your point, you should have mocked get service. I agree 100%. So here now is, minimize that. Oops, sorry. Here now, oh, I have stuff in my way. Okay. So here now is set bits running command. I want to make sure if bits is stopped, start it. If it's already running, say it's, well, don't do anything, it's already running. What does a test for that look like? Now, this is where we kind of get into test-driven development, and to be honest with you, I had a hard time wrapping my head around this. Like, how do I write tests first? How do I do that? I don't know how to do, right? How do I write tests first before I write stuff I want to solve? So like I said, I was a science teacher, and being in science, I experiment. I perform something first and see what happens after. So I guess to work toward test-driven development as, how do I put this? So I guess my opinion is if you solve the problem first or know how you want to solve it, it makes it easier to write the test first. So you kind of have to think about the problem and how you want to solve it before you can write your test. You can't just write a test and go, oh, now, all right, I have a test. I don't even know how to solve it. I don't know how I'm going to write my code. I don't know what I'm going to use to write my code or what function I'm going to use. It is difficult. So I basically started, I kind of cheat. I write my code first and I write a test after. And then basically it's two parts. Getting more familiar with the tool, Pester, getting more comfortable with that so that's not in your way. Then you can kind of focus on, all right, how do I apply more test-driven development philosophies in writing a test first? So back to this. So with test-driven development, we'll have unit tests. So I just want to test my code, and this is where we're getting just mocking get service, and now I have another function here I'm calling another commandlet, set service. So I'm actually going to mock both of those things in my unit test. And why am I doing that? A unit test is just testing the code that I wrote. So I'm not interested in testing set service. I'm not interested in testing get service, which is in my get bits function, which is what you saw earlier. I'm not interested in that. I want to make sure that the code I have in my function is what I'm looking at. So I'm basically evaluating my if block. If this, else do that. So here is my unit test for set bits running. So at the top, now this is a module, and as you can see, I have privatized functions and public functions. So I export these certain service functions. The private ones are not exported. So in order to actually use the private ones in my test, I have to use this in-module scope command, which is part of Pester. So I have to wrap my describe block around, within this in-scope module services. And the services is my module, and in-module scope basically loads that entire module, including the unexported functions, so the test can use it. Everyone follow along with that so far? Okay. So I start with my first mock in my describe block. Now mocks, describe and context blocks also have their own scopes. So if I mock something in my describe block here, it's available to all context blocks later on. If I mock something in a context block, it's only available within that context block. So it stays contained in there. So I mock set service at the top, because either way, in either criteria, I want the service to be running, period. So I mock it outside of both context scenarios, which is the service is already running or the service is stopped. I always want running to be returned from set service within set bits running. And in my context block, I mock my get service. Why am I mocking get service? So within set bits running, I call my get bits function. And my get bits function contains get service. So I'm mocking what actually is being executed, which is the get service commandlet. The same thing for set service. I'm mocking the set service commandlet, which is actually what's being executed. I don't care about testing that code. I just want to test my logic. So far, so good? Okay. So with all that said, I have my context of running. I mock my get. It should be running. Since it returns running, I should get, if the logic holds true, it should return or is running. If the service is stopped, I should then start the service. So then I return the service was stopped from the get service. I expect that to happen. It should happen. So then I execute set bits running. It should then run the service. Since I mocked that also, I expect it to be running. If my logic is working properly, it should just execute the code. And the last thing I have here is a cert verifiable mock. So one other parameter you can add to your mocks is verifiable. Then you add this assert verifiable mock, which is contained within the describe block. And that makes sure that all the mocks that you defined in the test are actually run. And if one of the mocks is not run, it will throw a failure and kick out the test. So let's see what this looks like. Okay, let's go back into here. I'll go into the directory where my tests are. Now I will invoke the test that I have open, which is set bits. And I'm going to use my tag of unit test because I only want this unit test, the name. I have two set bits tests. I only want the unit test to run. Execute that. Oh, no. Oh. See, I know how many times I rehearsed this, and I keep telling myself, make sure you open this in Run as Administrator. Hence, when I have at the top in my code, you might have seen this, requires Run as Administrator, to ensure that it works. Just give me a second here. I knew I was going to do this. Unbelievable.
You're not the only one that's got that today.
Hey, you know what? That was my first mistake ever. You know, it's caught live. There's evidence. There's no evidence of my first mistake. My wife's going to see that. I said, I knew you were wrong.
That's the first thing on your card. You know what? It's done.
That's it. All right, let's go back. Okay, here we go. Oh, what happened? All right. Back to test. Okay, let's try this again. Invoke Pester, the name of my test, which I forgot already again. Set bits, I think it was, yep. And my tag of unit. There we go. So it's going through all the tests. The only one it's going to execute is the one I specified, the set bits unit test. Executes that, and boom, we have a passing test. Yay! So what does the integration test look like? That's basically pretty simple as also. And I did this on purpose. I left the mocks in there. I just commented them out. So it's basically the same test. So what's nice is you can reuse the code that you've already created, copy, paste, adjust it for the test that you're basically trying to achieve, and that basically cuts down a lot of the time. So you don't have to keep rewriting the same test over and over. You just reuse it. You can reuse the code that you've already done, which I did here. I just reused my code. I commented out the mocks. Obviously, I would get rid of them, but I left them in there so you can see what I did, the changes I made. And I'm just letting the functions actually run now, and they're actually going to, it's actually going to make sure the service is running. Now, one thing I did here is once my service, to make sure my service is stopped, I'm actually executing a stop service command to make sure the service is actually stopped, and that it will then, the function will then start it. Now, I've done this a couple times, and the very first time I run it, for a reason it fails. And I expect it to happen now, and it did. I'm not sure why exactly that's happening, but when I run it again, it works fine. Oh, maybe. Oh, you're right, man, I have to put a weight. Yeah, I probably should put a weight in there. Good, see? I'm glad we're a bunch of smart people. Is there a weight?
It should wait by default.
It should.
Sometimes it doesn't like to.
Okay. Well, that's integration test. Okay. So putting it all together. So we did unit test. We learned how to mock that integration test, which is just let the function run, see what happens. And of course, I'm doing this against a test environment, not production. Putting it all together. Now, I mentioned before, I usually code against REST APIs. So I have a local instance of Octopus running on my machine here. And you see I have a Summit Rocks environment. Oops, let me go back to here. That I created going through my demo. So what's going to happen here is, as part of the test for this, my integration test will remove it ahead of time so it passes. So you see my public function I remove. I don't have a test for that. I just wrote it just to do the cleanup so my test can run. I probably should write the test for it, but I was a little lazy, sorry. Once again, I have a private function, get environment names, and this is where understanding what you need to mock is important. So let me do this quickly. Clear my screen. Where's my terminal? I'm going to execute these two lines here. Come on. Or not. There we go. That's probably not what I wanted to do. Where is it? There we go. So when I pass in results, this is what I'm getting. So Octopus returns to me this JSON blob, and it has a bunch of properties. And what I'm actually after is contained in the property items. So if I go result items, I'm basically getting the environments from my Octopus server. And if I specify the property results.items, I now get the two environments I want to get. So this took me a little while to get my head around, like, why can I mock my invoke rest method? Well, I had to make sure I understood what the command was returning me and how to actually get that information out of it. So what I'm basically doing in my unit test, in my new Octo environment, get this out of the way, get this out of the way, is I have to mock my invoke rest method, and I'm mocking the invoke rest method of the Octo of my get function in this context blocks, in this context block. And I had to create a property, so I'm returning a PS custom object, and that was also part of, if I did the actual object type was a PS custom object. So I'm making sure I'm just returning the same thing. So I return a PS custom object with a property of items, and that property of items contains other properties of ID, name, and description. And that's what Octopus uses to identify its environments. And if everything works great, if the environment already exists, it should return already exists. And if the environment doesn't exist, I'm now mocking the rest method of the post command, create the environment. And that's coming from my new Octa environment script. I'm actually mocking this, and when this completes here, it will return the JSON blob saying, here's your new environment with those properties that I have defined here in my unit test. It basically returns these properties. So if I go and execute this guy, get this out of the way. Okay. I always forget the name of my test. Test Octo environment. So I'm going to invoke Pester, name test Octo environment. I don't actually have to specify the name. So instead I'm going to do the tag. There's only 2 tests. I'm going to specify my unit test to run. And voila. Yay! Now the integration test, where it actually performs some stuff. So once again, I left the mocks in there. I just comment them out. I let the commands do what it needs to do. And before I see if the environment exists or not, I make sure it's not there. So I use the same environment name, create it, remove it, create it again, and I should see it there once again. So here we go. I'll tag the integration test this time. Execute that, and it should exist, and it does. And of course, it did remove it, push it back in, and you still see it. It's still there. Now I guess I can make you believers and make sure. Oh yeah, I almost forgot. Sorry. Back to my services one. Now, I was targeting certain amount of tests, so if I just invoke Pester here, in general, it will execute all the tests in my services module in this test folder I have located here. Go back. I know Pester's not the most exciting thing to present, trust me. It was not easy to make this fun. So it's going to invoke all this, so let's see what happens. I went through this a lot. All these tests should pass. Oh, wait a minute. Oh, there's that same one. Oh, wait, I have 2 others here. What's going on here? Well, let's look at what happens when a test fails and you don't expect it to. Let's see. Look at these 2. My set token running service, okay, it should return running. Expected running, but token service is already blazing. What the heck? Oh, let's actually fix that and make our test work again. I must have messed something up in my function. How did that happen? So, oh, there it is. Yeah, silly me. I don't know how that happened. I'll save that file. I'll rerun all the tests again. And there you have it. Yay. So, okay. That basically is all the demo information I have. Okay. So in summary, kind of sum everything back up. Simpler code, simpler tests. Small piece of code, small piece of test. Let's get ready for lunch. Start simple. Understand what to mock, like kind of what I explained. Now go pester yourself. Thank you for listening.